4th March 2026, and today we are planning to complete AC generator questions as well as transformer questions. So we are starting with AC generator. So what is AC generator? AC generator is a device which is used to produce electricity, which is used to convert mechanical energy into electrical energy. Mechanical energy into electrical energy. And its structure or construction is just like same as motor, but this is AC generator, so there is no commutator. So right now I have drawn two permanent magnets. Consider the left hand side is the north pole and the right hand side is the south pole. And consider there is a coil of wire, and this coil of wire I am drawing a vertical coil of wire. The coil is vertical, and the two ends of the coil are connected with two separate copper rings. Two separate copper rings. This is ring number one, and this is ring number two. These are two separate copper rings. And right now, the coil is vertical. When the coil is vertical, in the last class I taught you motional EMF. In motional EMF, I taught you if if a wire moves parallel to the field, if a wire moves parallel to the field, then there is no induced current, there is no EMF. So right now, the coil is vertical, and these are magnetic field lines. These are magnetic field lines, and when the coil is vertical, then the side of coil is moving parallel to the field. And you know, if a side is moving parallel to the magnetic field, then no current is produced. No current is produced. And no current means no EMF means I am starting my graph with origin. I am starting my graph with origin. When the coil is vertical, when the coil is vertical, induced EMF or induced current is zero. But when the coil turns, then obviously it becomes horizontal. And when the coil becomes horizontal, I am drawing a horizontal coil now. Consider this is consider this is a horizontal coil. When the coil is horizontal, and again the two sides of the coil attached with the copper ring, two separate copper rings. But the key word is this side and this side. You can see this side consider moving downward, and this side is moving upward. If the coil is turning clockwise, if the coil is turning clockwise, initially it was vertical and now it is horizontal. And when it is horizontal, then the two sides are moving perpendicular to the magnetic field. And now the induced EMF or the current will be maximum. So when the coil is horizontal, then these two sides, side PQ and side RS, these are moving. One of them is moving downward, the other one is moving upward. And when the two sides are moving perpendicular to the field, then EMF is maximum. And obviously, when the coil turns further, then it becomes again vertical. Then it becomes vertical, then again induced EMF will be zero. And as it continues to turn, then it becomes horizontal. When it becomes horizontal, then the EMF will be maximum, but in opposite direction. And again, the coil becomes vertical. So when a coil is turning and it is starting with vertical position, vertical, horizontal, vertical, horizontal, vertical, horizontal, then the coil makes one rotation. And when the coil makes one rotation, then one cycle of alternating current is produced. One cycle of induced current, one cycle of alternating current is produced. So when you start solving questions, then you will see most of the questions they will ask where the coil is horizontal, where the coil is vertical. So remember, if the magnets are placed on a horizontal table, then when coil is vertical, EMF is zero. When the coil is horizontal, EMF is maximum. So it is very important thing which I have explained. Number one. Number two, sir, voltage produced by voltage produced by generator. Its equation is this. Sir, what is this? Actually, voltage. V for voltage. Sir, voltage depends upon Nawab. Voltage depends upon Nawab. Sir, who is Nawab? I am explaining. Actually, this N represents number of turns of coil. Number of turns of coil. When I draw, this is a rectangular coil. Actually, it is not a rectangular coil. Right now, I have drawn the frame of the coil. This is the frame of the coil. Actually, coil is this, which I am winding on the frame. So when I wind coil on the frame, then number of turns, it will define voltage value. If the number of turns are greater, then greater voltage will be produced. If the number of turns are lesser, then less voltage will be produced. So this N represents number of turns. So this V is velocity. Velocity means the speed. When the coil turns faster, it will produce greater voltage. So what is A? A is the area of the coil. A is the area of the coil. Area means if the coil is smaller in size, then obviously it will produce less voltage. If the coil is large size, then it will produce greater voltage. So what is B? Actually, B in A level physics, or if you search on Google, then B represent always strength of magnetic field. Strength of magnet. If you use a strong magnet, this B is a symbol of strength of magnet. If you use a strong magnet, it will produce strong voltage, greater voltage, etc. So you should memorize this formula, and the formula is voltage in generator is Nawab, and in this Nawab, this V should be in small letter so that you can differentiate between this is voltage and this is velocity. So voltage is equal to Nawab, number one. Number two, you should memorize this graph. When the coil is horizontal, there is maximum voltage. When the coil is vertical, then there is minimum voltage. So I have taught you very fast AC generator, and now we can solve questions. So this is question number one. May June 2021. In this diagram, you can write this is magnet. Yes, it is permanent magnet. So this is coil of wire. Yes. So these are two copper rings. Copper ring. This is one ring. This is second ring. There are two rings. And again, this is carbon brush. This is carbon brush. And these are external terminals which will supply you produced current or voltage. And now the question is, a student is rotating the handle. This is the handle. This is the handle. And a student is rotating this handle. And obviously, when the handle is rotated, the coil will turn in the magnetic field. The coil will turn in the magnetic field. And now the question is, sketch a graph to show how EMF between the terminals X and Y varies with time during two complete revolution of the coil. So, sir, it is very, very simple. Sir, we will draw this is one cycle, this is one cycle, and try to draw another cycle with same time period. So these are two cycles, two complete revolution of the coil I have drawn on the graph paper. Number one. Number two, they are asking They are asking mark with a mark and label a point P when the coil is horizontal. हाँ बेटा आतिफ, can you tell me where is the coil is horizontal, or when the coil is horizontal, then EMF is maximum or minimum when the coil is horizontal? Atif, maximum. So this is maximum voltage, and when the voltage is maximum, then the coil is horizontal, and this horizontal coil is labeled as P. So this mark P representing the coil is horizontal. This P representing the coil is horizontal. Okay. And now they are not asking about vertical, but I am writing. I am writing. Sir, here will be vertical and this is horizontal. Okay, it is my extra mark. And now the student turns the handle more quickly. More quickly. It means the speed of the coil rotation is increased. And you know, हाँ बेटा राफे, जी बिल्कुल मैक्सिमम मैक्सिमम है। हाँ हाँ नीचे वाला भी सही है, नीचे वाला भी सही है। Actually, the graph below the x-axis, it shows that the direction of the current is reversed. The direction of the current is reversed. When current produced and come into the circuit, then this is called positive cycle of the current. And when current changes its direction, then this is the cycle. So this is incoming current and it is opposite direction current. So below x-axis direction is reversed, but the value of current or voltage will be maximum when the coil is horizontal. And now the question is, when the student turning the handle more quickly, then state two ways in which the EMF between X and Y will change. So I am answering. So sir, when the coil is rotating at higher speed, more quickly, then greater voltage will be produced. Greater voltage will be produced. In this question, they are not asking to draw. They are not asking to draw, but I am only to explain you. If the coil is turning at high speed, then voltage will be higher. And higher voltage means I will draw graph between these two lines. Number one. Number two, sir, when the coil turns faster, then obviously one cycle will be completed in lesser time. If a coil is turning faster, then obviously it will take less time to complete one rotation. So I am considering one cycle is completed in this time. So I am drawing, although in this question they are not asking to draw. So this will be the cycle. This will be the cycle. And in the cycle, you can see the peak values are increased as well as the time to complete one cycle is reduced. The time to complete one cycle is reduced. And I think this line is not at the right position. And now I think if I draw again, then it is better, more better, not a perfect. Okay, so the peak value of EMF will increase. Greater voltage, so peak value will increase. Initially, it was the peak value, but when the coil is rotating faster, then the peak value is increased. Peak value is increased. Number one. Number two, time period of cycle will decrease. Okay. Initially, consider it was completing one cycle in 10 milliseconds, but in this graph, the green graph, it is completing in 6 milliseconds. It means the time period of the cycle will decrease. The time period of the cycle will decrease as well as the peak value is increased. Peak value increase, time period decrease. And now the next part is about transformer. But right now, I'm not interested in transformer. We will start transformer 15 minutes later. And now we have another question. We have another question on generator. The question is, a student is turning the handle of an alternating current generator and the coil rotates, represent the structure of generator. Okay. There is an alternating voltage output between the two terminals. The question is, explain why rotating the coil produces an output voltage. Sir, when the coil is rotating, sir, the coil is cutting magnetic field lines. And we have studied when a coil or when a wire is cutting magnetic field lines, then induced voltage is produced with changing. So it is an extra word which I should not write. So the voltage direction will be changing and its value will also be changing because we have discussed this graph showing that the direction changing as well as the magnitude is changing. Direction changing as well as magnitude is changing. And now the question is, sir, state the position of coil when the voltage is maximum. But Amna, can you answer me when the voltage is maximum? You are given two position, horizontal coil or vertical coil. When the voltage is maximum. Ji, Amna beta, when maximum voltage is produced, you can see this graph as well. When maximum when maximum voltage is produced. इधर आ. When maximum voltage is produced. Amna, I think your microphone is not working. But here, can you answer me? When maximum voltage is produced? Yes, simple. So I'm writing the answer. In horizontal, in horizontal position of coil, the voltage is maximum, and they are asking why. Why? So I have explained in the last class. So when the coil is horizontal position, uh, sides of coil, sides of coil moving perpendicular to the field, perpendicular to the field, and cutting maximum magnetic lines. Cutting maximum magnetic lines. I am explaining. I am explaining. देखिए बेटा, the magnetic field is horizontal. The magnetic field is horizontal. Okay, but when the coil is in horizontal position, then this side of the coil actually it is moving upward, and this side of the coil is moving downward. This side moving upward, this coil is moving downward. Okay, so the magnetic field and the movement of sides are perpendicular. And when they are perpendicular, then the coil cutting maximum number of magnetic lines. The coil is cutting maximum number of magnetic lines. And when maximum lines cutting, then there will be maximum voltage will be produced. So when the coil is horizontal, there will be maximum voltage. And now the switch is closed. Now the switch is closed and the lamp lights up. The student has to apply a greater force on the handle. The question is why greater force is needed to keep the lamp lit. Okay. So the question is consider initially there is no load. Consider there is no load here. If there is no load, if there is no load, then obviously there is no resistance. And when there is no resistance, then it is very easy to rotate the handle because electricity is being produced, but due to no load, so no resistance. And when there is no resistance, so there is no conversion of energy. There is no conversion of electrical energy into the other form of energy. But if you connect a load here, consider, sir, we are connecting a lamp here. Consider this is a lamp. And when you connect a lamp, now read the question, sir. Now a lamp is connected between the output terminals, and now the student has to apply greater force. Now student has to apply greater force. So the question is why greater force is required. So I am answering. I am answering. Sir, electrical energy converting into light. So more energy is required to produce electricity, as well as due to resistance of lamp, greater force is required to turn the coil. Okay, so when there is no load, sorry, if there is no load, then it is very easy to turn the handle. It is very easy to turn the handle if there is no load, sir. But when you connect a load, and let me check, sir, is there marking scheme I have connected? Yes, sir, marking scheme is here. And if we read the marking scheme answer, then it will be more better for you. So right now we were solving question number 109, 109. And if we read answer from the marking scheme, so the answer is the current in the magnetic field experience of force, energy supplied is converted into light energy. So a student must do more work to produce more energy, more electrical energy. So greater force is required to do work. So I have written this answer. And in the first part, sir, in the first part, actually examiner asking or writing this answer according to Lenz's law. According to Lenz's law. And according to Lenz's law, due to the current, an opposing force is produced. Due to the current, an opposing force is produced. So you may write any one answer. So my answer is also right, in which I am saying, sir, electrical energy is converting into light energy. So more energy is required to produce electricity. As well as there is a resistance of lamp, so student needs more force required to turn that coil. As well as according to Lenz's law, you can answer. So according to Lenz's law, when current is produced, then this current opposes the movement of the coil. According to Lenz's law, the induced current opposes the movement of coil. That is why student need more force to turn the handle. And now this is the third question, but I think it is the same type question, so we should not solve. Again, they are asking to draw the graph. You have to draw the graph. Simply, you have to draw the graph. And they are asking why EMF is produced, we have studied. And now I think state the name of the components labeled P and Q and state their purpose. P and Q. Sir, what is P? What is Q? Let's check. Sir, this is the P. This is P and this is Q. Sir, P and Q, what is their name? The Pavitra, can you tell me what is the name of P and Q? Pavitra beta, what is the name of P and Q? G beta? Oh my God. Split ring commutator was in motor. Okay. DC motor, split ring commutator. This is not motor beta. Pavitra, it is not commutator. G, Navia, can you tell me what is P and Q? Yes. This P and Q are called slip rings because these are complete rings in which the two ends of the coil are turning. Okay, so these are called slip rings because the ends of the coil are slipping inside the ring. So these are called slip rings. So their name is copper slip rings or slip rings. Okay, in generator slip rings are used. And what is their purpose? So the purpose is actually these are terminals to supply output current. We receive current through these terminals, and these terminals are called slip rings. So P and Q are slip rings, and their function, their purpose is these are terminals, and these are used to supply output current. And now state two possible changes that causes a larger EMF to be induced. So they are asking, sir, we have to produce larger EMF. So use strong magnet, use strong magnet, number one. Number two, rotate coil at high speed. Okay, and actually it is Nawab. Nawab means increasing speed, increasing strength of magnet. Okay, but you can write, sir, increase number of turns of the coil, increase the area of the coil, all are correct. But usually in marking scheme, they write only use strong magnet. Number two, rotate coil at high speed. So this question is also completed. And now, sir, what is the difference between DC and AC? Sir, DC flows in one direction, DC flows in one direction, and DC is a steady current. DC is a steady current. And if someone asks me to draw uh, the graph of DC, then the graph of DC is like this. This is the graph of DC. Consider the voltage is 4, and you can see its value remains constant. Number one. Number two, no change in direction. Neither direction changing nor value changing. So it is steady DC. Steady DC. Okay. Whereas alternating current. So alternating current, its direction reverses. Number two, its value also increase, decrease, increase, decrease. So direction reverses as well as value fluctuate. And now we have a question. So the question is, sir, we are given a voltage graph. हाँ बेटा, we are given voltage graph and we have to draw the current graph. Okay. Sir, how can we draw? So I am explaining you. Sir, according to Ohm's law, sir, voltage and current are directly proportional. And if the two quantities are directly proportional, then their graph will be of same shape. Their shape will be same. Their shape will be same. Okay. So I can say the graph will be like this. The graph will be like this. Same shape graph will be here. Number one. Number two, sir, we are given some values. So we will draw the graph according to the values. Sir, what values are given? So the values are given like this. A heater is connected, AC generator, and maximum current is 0.75 ampere. So maximum current is 0.75 ampere. So I am drawing a boundary in which I have to draw this graph. This is the boundary. Okay, number one. Number two, so the graph cycle. Sir, graph cycle. Sir, starting from this point. राफे बेटा आपको मेरी स्क्रीन बिल्कुल सही नजर आ रही है? स्क्रीन में कोई प्रॉब्लम तो नहीं है? थोड़ी सी ब्लर हुई हुई है, क्यों ब्लर हो गई है? इंटरनेट तो मेरा बिल्कुल सही चल रहा है। अच्छा। अच्छा, मैं इसको अगर दोबारा शेयर करूं, रुक जाए। इफ आई स्टॉप शेयरिंग, आई हैव स्टॉप शेयरिंग एंड नाउ अगेन शेयरिंग। देखें इससे कोई फर्क पड़ा? जी बेटा बताइए। राफे बताइए, क्या आपको अब स्क्रीन जो वैसी वाली स्क्रीन है साफ नजर आ रही? पढ़ा जा रहा है। और इस वाले पेज के ऊपर भी अब जो कुछ है आपके सामने पढ़ा जा रहा है? ठीक है। अच्छा बेटा, आई एम ड्राइंग ग्राफ एंड आई एम copying pasting the same type of graph because voltage and current are directly proportional. Voltage and current are directly proportional. So the graph will be bit through these points which I have drawn, and now I am erasing boundary, and now I am joining these points. Okay, beta. So I think I have drawn same shape. चले ठीक है, चले ठीक। ठीक है जनाब, so right now sir, both graph are of same shape, but obviously both graph are on different pages, so I cannot zoom in, zoom out. So right now I think it is clear, and in this graph the graph shape is same. The graph shape is same. So you are given voltage graph, you can draw current graph of the same shape, same time, etc. Okay, and now they are asking power calculate power when the current is 0.75 ampere. But here, do you know any formula to calculate electrical power? Here, अच्छा हीर भी नहीं है क्लास में। आमना भी ड्रॉप हो गई, हीर भी ड्रॉप हो गई। हाय हाय, तीनों बच्चे ड्रॉप हो गए, क्यों? इनका इंटरनेट सही नहीं आ रहा क्या? अरे चले, नेवी आप हमें बताइए। बेटा नेवी आप हमें बताइए, व्हाट इज द इक्वेशन ऑफ पावर? करंट टाइम्स वोल्टेज। When the current is 0.75 ampere, then the voltage is this value. And what is this value? So we have to read, sir, this is 6.4, 6.8, 7.2. This number is 7.2. So the voltage is 7.2. So if you multiply 7.2 with 0.75, then beta, what is power? Nevia, what is power? Electrical power is the product of these 5.4. And the unit is watts. Okay. And now again the coil is turning. Draw a straight arrows to indicate the direction in which side AB of the coil is moving. Okay. So the question is, right now side AB is turning. And if the side AB is turning, then the question is draw a straight arrow to indicate the direction. In which direction the side AB is moving. So I think most of the student can think, sir, AB is moving like this, and side CD will be moving like this. Although they are not asking about CD, they are asking, sir, what is the direction of side AB? So, beta Pavitra, my arrow, my green arrow is right or wrong? Beta Pavitra, my green arrow is right or wrong? Pavitra is not answering. When the coil is turning, and right now it is horizontal, I have taught you earlier. So when the coil is horizontal, then that these two sides are moving vertically upward or downward. Okay, vertically upward or downward. So the right answer is this, which I have drawn right now. Okay, so when the coil is horizontal, then the side AB is moving vertically upward, and the side CD is moving vertically downward. So these are direction of the two sides. And now deduce the direction of current inside AB. Oh my God. They are asking what is the direction of current? What is the direction of current inside AB? And I did not teach you in the last class the direction of current when a wire is moving in a magnetic field. The direction of current is determined by which hand rule? I am asking you. राफे बताना कौन सा राइट हैंड रूल या लेफ्ट हैंड रूल लगेगा टू डिटरमिन द डायरेक्शन ऑफ करंट. लेफ्ट हैंड रूल लगेगा. ठीक है. बिल्कुल गलत आंसर है. सर राइट हैंड रूल विल बी यूज्ड. राइट हैंड रूल is used. Sir, why are you using right hand rule? So I am showing you with my notes and explaining the rule as well. Set number two. अच्छा मैंने तुम्हें राफे ये वाली बात पढ़ाई भी है कि whenever they ask the direction of force, we use left hand rule. Direction of force, left hand rule. Only force direction is determined by left hand rule. Okay. And right now you can see this is generator topic. This is generator topic. And in generator, the coil is moving. And when the coil is moving, when the coil is moving, then I am showing you this. Sir, right now, the magnetic field is from north to south, from north to south. Okay. And in this north to south, you will place your first forefinger of the right hand. Right hand first finger from north to south. Number one. Number two. So the coil is moving, consider upward. If the coil is moving upward, if the coil is moving upward, then thumb in the direction of motion. This is north to south first finger. First finger north to south. First finger north to south. Thumb in the direction of motion. Then your second finger. Then your second finger will tell you the direction of current. And you can see this is the direction of current. In this diagram, you can see this is the direction of current. Okay. So in generator, sir, we use right hand rule. In generator, we use right hand rule. And the right hand rule I have explained as well as I am sharing you this screenshot with you so that you can memorize according to right hand rule. So this is right hand rule, and in this right hand rule, we have determined the direction of current. Okay, and now we are shifting back to our this page. G, the first thing we will use right hand rule, and I am interested to apply this right hand rule with Atif. But Atif, can you help me to apply right hand rule? Atif bhai, can you help me to apply right hand rule? Okay. And I am asking you to keep your right hand first finger from north to south. Can you do it? Right hand first finger from north to south. And I have to change the position of my screen, but I have rotated my screen, or you may stand up. Okay. Haji, or and in your exam, obviously you will have a printed page, so you can easily turn the page. Okay, so no problem. So my first finger is from north to south, and my thumb is upward. My thumb is upward. Atif, where is the direction of current in AB? From A to B or B to A? Right hand rule. B to A. Your answer is totally wrong because my second finger is pointing, so the direction of the current is from A to B. The direction of current is A to B. The direction of current is A to B. I am repeating again. But Atif, apply again, beta. Apply again. So the first finger from north to south, first finger, and this is right hand rule. Right hand rule. And remember, when I am writing right hand rule, I am writing right hand rule, and then I am taking G as a common. I am taking G as a common. And it is a standard rule, sir. Right hand rule, it is also known as generator rule. Generator rule. In generator, you have to apply right hand rule. In generator, you have to apply right hand rule. And for force, left hand rule. For force, left hand rule. Right now, we are studying generator, so I am applying right hand rule. G, my first finger, north to south. My first finger, north to south. My thumb pointing upward. And when my thumb is pointing upward, then my second finger is pointing from A to B. A to B. From A to B using right hand rule. Okay, but we have used right hand rule, and by right hand rule, the direction of current is from A to B. The direction of current is from A to B. Okay. And now the third part, the rate at which the coil of the AC generator rotates increase. It means you are rotating the coil at faster speed. Then two ways, alternating voltage change. Sir, we have studied peak value will increase. Peak value will increase, greater voltage produce, time period will decrease. Time period decrease. Sir, we have discussed already these 2 points. And now again, question number 112. The coil completes one rotation in 0.02 second. So, sir, we are given that we have to complete one cycle within this time period. We have to complete one cycle within this time period. So I can draw. So this is the half cycle. This is the complete cycle. This is the half cycle. This is the complete cycle. And now again the question is, sir, where the coil is vertical? Where the coil is vertical? And mark this point as A. So, sir, when the coil is vertical, you know voltage will be max minimum zero. Okay. So this point A represents vertical position of the coil. This is not generator question. Now this is generator question. Again, same type question. And again, they are asking where is the coil is horizontal. So horizontal is here. Horizontal is here. Vertical is here. So I have already taught you that they ask again and again these 2 points. And I think generator is enough because same kind questions are rotated. Same kind questions repeated. So we should not continue. So AC generator is completed. AC generator is completed. And tomorrow we will start transformer. We will start transformer. But